So in this class we solve another problem on series solution of differential equation. So here the problem is solve in a series the equation d square y by dx square minus y equal to 0. Now call this equation as 1. Okay, so now comparing the given equation 1 with p0 of x d square y by dx square plus p1 of x dy by dx plus p2 of x y equal to 0. On comparing these two, we obtain p0 of x is equal to 1, correct? So which implies at x equal to 0, p0 of 0 is equal to what? 1, and it is not equal to 0. Okay, so therefore x equal to 0 is an ordinary point. So therefore let y is equal to a0 plus a1x plus a2x square plus a3x cube plus a4x raised to 4 and so on, okay, be the solution of equation 1, right? So now here what we have, d square y by dx square minus y, means we have to differentiate 2 times. So dy by dx is equal to, on differentiating this is 0, then plus this is a1 plus 2a2x plus 3a3x square plus 4a4x cube and so on. Next, differentiating again, we get d square y by dx square, this is again 0, this is 0, okay, then plus this is 2a2, then this is 6a3x, this is 12a4x square and so on. Okay, so now substituting all these, substituting d square y by dx square and y in 1. Okay, so then we get, this is 2a2, first d square y by dx square, so 2a2 plus 6a3x plus 12a4x square and dash so on. Okay, and next is what? Minus y. Okay, minus y means a0 plus a1x plus a2x square plus a3x cube plus a4x raised to 4 and so on equal to 0. Okay, equal to 0. Okay, so next what we do, equating the constants to 0. Okay, so here what is the constant? This is 2a2, one constant, then plus and minus, so minus a0, here also one constant is there, so is equal to 0, or 2a2 is equal to a0, a2 is equal to a0 by 2. Next, equating the coefficient of x to 0. Okay, so let us find coefficient of x. So here x is there, its coefficient is 6a3, correct? So this is 6a3. Then this x square, and next here minus, here one more x is there, its coefficient is a1, minus a1. Okay, so next there is no other term of x, so equal to 0, equal to 0. That means 6a3 is equal to a1, or a3 is equal to a1 by 6. a3 is equal to a1 by 6. Okay, and after getting all these things, next equating the coefficient of x raised to n to 0. So what we obtain? So here x raised to n means when it is n, when it is x raised to n. Okay, now see here, when x is equal to 2, then this is 4. When x is equal to 1, this is 3, correct? When x is equal to 1, this is 3. When x is equal to 2, this is 4. When x is equal to n, right? And then when x is equal to 1, this is equal to what? 6. Means it is 3 factorial, right? 3 factorial, and it is 4 factorial. 4 into 3 into 2 into 1. So 4 into 3, 12, 12 to the 24. No. So 12a4 x square, equating the coefficient of x raised to n. So we obtain so similarly here, if I take the last term as an into x raised to n, then dy by dx becomes n into, here it is n into x raised to n minus 1, and so on. Then d square by dx square becomes n into n minus 1 into x raised to n minus 2. Okay, so this is nth term, this is nth term. So I write this term here plus dash 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 after differentiating n into n minus 1 into x raised to n minus 2, x raised to n minus 2. I write here. Okay, so this is d square y by dx square. So to get coefficient of x raised to n, here I replace n by n plus 2, n by n plus 2. Then it becomes n plus 2 into n plus, if here also I replace n plus 2. Okay, so this is replaced by n plus 2, and here also it is replaced by n plus 2. So n plus 2 into n plus 2 minus 1, so n plus 1 into, here I replace n plus 2, plus 2 minus 2 get cancelled. So only x raised to n remains. So it is n plus 2 into n plus 1. Okay, so in this case we obtain n plus 2 into n plus 1. Okay, n plus 2 into n plus 1. Okay, then plus into, then one more term is there, this is an, right? This is an means it is into an comes, so this becomes a, and I replace n by n plus 2, it is n plus 2, then plus in the next term here, coefficient of x raised to n means what? It is a raised to n, so an, so this is minus an, this is minus an equal to 0. So now I need an plus 2, so therefore an plus 2 into n plus 1 into n plus 2 is equal to an. So therefore an plus 2 is equal to an divided by n plus 1 into n plus 2, n plus 1 into n plus 2. So now we got two values, that is we got a2, right, in terms of a1, a0, and we got a3 in terms of a1. Now we find next value. Okay, so here a4, so put n is equal to 2, so we get 2 plus 2, that is 4, this is 2 divided by, so means 3 into 2 means 3 into 4, which is equal to a2 divided by 12, a2 divided by 12. Okay, now what is a2? a2 is what? a0 by 2. So therefore here a2 is a0 by 2 by 12, or which is equal to a0 divided by 2 into 12, 24. Next put n is equal to 3, then this a5 becomes a3 divided by 3 means 3 into 3 plus 1 4, 3 plus 2 5, so a3 divided by 20. So what is a3? Already we found this a3 is a1 by 6, this is a1 by 6 divided by 20, or a1 divided by 6 into 20, 120, a1 by 120. So like that we obtain all the values of a4, a5 and so on. So with this the solution is y is equal to a0 means a0, a1 x same. Next a2 is, so this is a2, a0 by 2, a0 by 2 x square plus, okay, a1 a2, then a3 means a1 by 6, a3 means a1 by 6, so a1 by 6 into x cube plus, this is a0, a1, a2, a3. Next a4, so we found this a4 as a0 by 24, so a0 by 24 into x raised to 4 plus a5, this is a5, a1 by 120, a1 by 120 x raised to 5 and so on we get. So this is the solution of the given differential equation. So with this I conclude this class and continue in the next class. Thank you.